Hello friends, welcome to my channel. Myself Vignesh Anand. Uh, in my channel, most of them will be videos will be about our electrical substation related equipments or even circuits. So please share your knowledge and also sharing my knowledge so we can gain our knowledge. So coming to the topic, today we are going to see about the basics of transformer. So normally the transformer is a static device which transfers a AC electrical power from voltage one voltage to another voltage, keeping the frequency by same by the electromagnetic induction, which means the transformer normally works under the principle of electromagnetic induction. And also static, in the sense static means there is no movable part in a transformer, which means a transformer consisting of a primary winding, secondary winding, then cores. So within this, by a mutual induction principle, the transformer works. So next thing, mainly the transformer types. Based on core, it is differentiated into a core type and shell type. Core type means Core type means a cores which is surrounded by a winding. Shell type means windings in between the shells, which means like a shell, like normal shells. How the shells will be there? The shells will be in outside side, inner side. One small thing will be there. Like this, just for an assumption, I am saying here. Then, uh, based on the phases, it is divided into a single phase and three phase. Then, upon the ratios, it is divided into a step up and step down. Then, upon their service, it is divided into a power and distribution transformers. So, in this power transformer will be mainly in a generating side of our stations, and the distribution transformer will be used for auxiliary supplies or even for consumers everywhere. So, these are all the types of transformers. Then what can be what and all the faults which will be happening in a transformer? So based on that, internal and external faults are there. Internal faults which consist of phase faults, ground faults, then tap changer failures, leakage of oil from a taps. These are all normal internal faults. Then external faults will be a overload fault, then overfluxing fault. These are all the common normal external faults. And also there are more number of faults in transformers. I am just written right now for a basic understanding. I have only written the common faults. Then what and all the body protections, which means the transformer itself we have some protections. If the transformer get failed, in that time we need to know about that, know about the failures. So for that we are using these protections. Buchholz relays, which means a gas operated relay. It will be placed in between the main tank and conservator tanks of a transformer. So whenever the oil get overheated, it will get stressed, and after sometimes if the transformer is de-energized, then automatically the oil will get enlarged. So in that time also there is many problems will be there. So for that we are using breathers and everything and all for that. So while overheating of oil, the oil get evaporated at some time. So in that time, the evaporated air will go, which means the gas molecules will goes into the Buchholz relay. In that Buchholz relay, some few amount of oil is inserted in it. In that, the air get inside the Buchholz relay, and automatically it initiates the uh, low level of oil, and automatically the alarm and trips will be initiated. Same wise, the oil surge relays are being used. Then pressure relief vents, which is written as a pressure relief device. This is also used at the time over pressuring. The alarm will be initiated. Then RTD, resistance temperature device, which means oil temperature, winding temperature, and all connected to a system by using this resistant temperature device. This is our oil level indicator, which this oil level indicator is connected with our conservator tank of transformer. Then oil winding temperature gauges. This RTD is connected with this temperature gauge parallelly, and also to our SCADA system, which is used in power plants and also in substations. Then main part of a transformer. The transformer consists of a Buchholz relay. As I have earlier explained, the Buchholz relay, which is a main part of our transformer, and also these Buchholz relays are used in a 500 kVA transformers minimum of, because it is also a economical based. So Buchholz relays will be mostly used in more than 500 or even at 300 kVA transformers. After I'm saying that, then main tank. This main tank consists of our primary and secondary windings of our transformer. Then a radiator. This is a cooling system, one of the cooling system which is used in a transformer. Then expansion valves, vents. This consists of valves like shut-off valves, drain valves for our purpose of filling and draining the transformers. So this and all comes into the expansion system. Then oil level indicator. The oil level indicator is commonly connected with our conservator tank of our transformer, so we can easily able to know the level of oil in our transformer. Then oil and winding temperature gauges. These gauges are indicates the temperature of our oil inside the transformer and also the winding inside the transformer. Then tap changer. This tap changer is basically used to change the taps, which means the accurate voltage in which we can get an accurate voltage, or else as voltage needed for our substation in a desired level, we can change with the help of tap changer. So this tap changer is basically connected in our primary side of our transformer, because the secondary side is connected with the load. So if we use the transformer by connected with the load side, which means on the secondary side tap changer is connected, means it will be a very difficulty for us, and also it is not a good idea for using the transformers in such a way. So on the source side we have connected the tap changer, and this tap changer is mainly used as a on-load tap changer and off-load tap changer. The on-load tap changer means while at the time of charging of transformer, or after charging of transformer also, the on-load tap changer can work. But the off-load tap changer means we need to de-energize the transformer, and then only we can use for tap changing. The next thing is HV, LV, and neutral bushings. These bushings consist of maybe consists of CTs, and the CTs are used for measuring and protection purpose also. This HV and LV and neutral bushings, which is connected with our bus sections, which means our jumpers, connectors, which is mainly used for connecting only. Then filter valves, then oil filling plugs. These are all commonly used for filtering of our transformers. Then oil filling pumps, plugs, which means the drain valves, as I have earlier said, the drain valves, then shut-off valves. These are all comes into the oil filling plugs. Then relief vents. Pressure relief vents are commonly used for relieving of our pressure inside the tank, which means the main tank. So this will be characterized into a three four varieties, like if the pressure vent is connected with our main tank, if the pressure vent is connected with our any other side of our tank, which means the mostly the pressure vents are used for relief of our pressure inside of our main tank only. Then cooling system. The cooling system is basically classified into 5 types: oil natural and air natural, which means uh, we don't use any fans or pumps for feeding the oil inside of our which means oil for cooling purpose. We are not using any of the fans or pumps. In oil natural air forced, we have used an air like a fans for feeding the oil inside of our radiator systems. Then oil forced, air forced. In this section, we use both the pumps and fans for feeding the radiators inside the oil, and we can get easily cooled the oil, which means the fan act like an exhaust fans, which sucks the heat from the oil and turns it out, and the pump which feeds the oil forcefully inside the radiator systems. Then oil forced, air natural. Same wise, in here pumps are used, and also the cooling system pumps are used, and also there is no fan uses. So we can say as a oil forced, air natural. Then next one, oil direct, air forced, which means in here the radiator system is directly connected with our internal parts of our transformer side, which means side of our transformer. From there, the oil will get automatically circulated in our radiator, and in between we will use an air force, which means like a fans in the surrounded by the radiators. So these are all the common parts of our transformers. So yes, in this next video we will check about the transformer testings, and also about the transformer varieties of testings, and also protections. So please check my next videos also, and also please check my before videos for any substation related, equipment related testing or anything. So have a nice day and see you soon. Bye. Thank you everyone. வாழ்க வளமுடன்.